Hello everybody, and welcome back for another math video. This is practice 41 on page 40 of your workbook, and we are looking at the volume formula today. Please make sure that you have watched the videos, the lesson videos, so that you understand what volume is and how it works. And let's put those skills to practice. The instructions are very important here, so I want to make sure that we notice those. It says to use the formulas where V is volume, L is length, W is width, H is height, and B is the area of the base. So we will be referring to these formulas. Number 1. Darnell swims laps in a lane that measures 25 meters long, 2 meters wide, and 3 meters deep. What is the volume of the lap lane? So I am going to sketch you a picture of this one. I'm going to try anyway. So there is the length. Let me copy that and paste it in here. And then we connect the vertices, the corners. So this is the lane in which he is swimming. And I'm going to try, I'm not sure that I can, maybe, yes, to take out some of this for you so that your eye can discern a little bit clearer what we're looking at. So this swim lane is full of water, and it's 25 meters long, 2 meters wide, and 3 meters deep. Now, I wanted to draw that for you because I want you to make sure that your units match. If they don't, we have to convert them. So you've got meters, meters, and meters. The answers are in meters, so this one's good to go. We're ready to do our formula. And the formula that we need is volume equals length times width times height. So volume equals 25 times 2 times 3. And use your calculator. Yes, you can use a calculator here. So 25 times 2, that's 50, times 3 is 150. And that is meters cubic because we're doing volume. So the answer to number 1 is B. Okay, so number 2, the inside of a microwave is 13 inches long, 14 inches wide, and 9 inches tall. What is the volume inside the microwave? Okay, on this one, I'm not going to draw the microwave. I'm going to draw what I call a variable box, where you put your variables in there that are part of your formula. And actually, I really need, this is a habit I'm trying to break, I need to put the V in there too. So volume, length, width, and height are the variables. They tell me that the 13 inches is length, 14 wide, 9 inches tall, that's the same as a height. So we have 13L, W is 14, and 9 is the height. And all of them are in inches. So volume is going to be what we're looking for. So we put that into the formula, 13, 14, and 9. And then we put this into the calculator. I really like these problems because I like things that are orderly and step by step. That's how my mind works. So these really make sense to me. They're step by step. You almost have a recipe for, you do have a recipe. It's a formula. Alrighty, so this one is 1,638 cubic inches. And that goes in there. Number 3. The area of the floor in a moving truck is 119 square feet. The height of the truck is 6 feet. What is the volume of the moving truck? I'm going to draw this one for you because I want to show you exactly what they're talking about. So here's one side of the truck. Here is the other side. And then I'm going to connect the vertices. Those need to be straight. Let me get a straight line. Connect the vertices. And you've drawn the bed of this truck, or this moving, not moving, the capacity of the truck. So let me take out some lines just to let your eye see a little more clearly. Actually, that's not what I want to take out. I don't want to take out. I want to color in. So here is the floor of this truck. Okay. And they have already told me that the area of the floor is 119 square feet. That's what they're telling me right here. The area of the floor is 119 square feet. And the height of the truck is 6 feet. So I'm checking these units to make sure they match, and they do. I've got square feet and feet. That is okay. As long as you don't have yards or inches in there, you're fine. So what this means to me is that I need a different formula. They've already done the length times width part. So the formula that we need is actually this one up here. V equals B times H. When I was in school, we didn't use this, so I'm having to get used to it. V equals B times H. B is the yellow part. It's the base area that they're talking about. So when I plug this one into my calculator, I'm going to use the 119 for the base area, and the height is 6. So I will do that problem on my calculator. 119 times 6 is 714, and volume is always cubic feet. So I like answer D for this one. But I wanted to show you what that big B means, and it is that yellow part in my formula. Okay, number 4. I love this one. What is the volume of this solid? I don't have a formula, thank goodness. I don't want a formula on this one. All I have to do is count the cubes. So I have 1, 2, 3, 4. Don't count them twice. 5, 6, 7, 8, 9. But be very, very careful. Is it 9 cubic? It's not. There's a hidden cube under that 5, because that 5 is up a layer. So there has to be a cube under there that we can't see. Another way that you can do it is to look at this layer and count in your head how many there would be. So let me remove the, let's do these. Just let's count them. Here is 1, 2, 3. I can't see that one under there, but it's under there. So 4, 5, 6, 7. There are 7 cubes in this layer. And then on top, there are 3 cubes. So there are actually 10 of them. You've got to count that one that you can't see. So be careful. You have to think through that one. And they throw that 9 in as a distractor in case you miss that cube that you can't see. Number 5. A jewelry box is 15 centimeters long, 20 centimeters wide, and 7 centimeters tall. Which 2 equations represent the volume of the jewelry box? I'm going to use a variable box on this one, but you could also draw the picture. So my formula is V equals LWH. V equals LWH, where length, that's long, centimeters, 20 centimeters, and 7 centimeters tall. So we have all centimeters. That's a good thing. So let's do 15 times 20 times 7. I see one of my answers. That would be E. So let's go ahead and solve this. You notice I left some space there. I'll show you why in just a minute. Normally I would not do that. 15 times 20 times 7 is 2100 cubic centimeters. But that's not one of my choices. So let me show you something here that they like to do. What is 15 times 20 on your calculator? That is 300 times 7. So sometimes they will take it step by step. They'll break it down one step at a time. Then 300 times 7 would be 21. But this answer is actually one that you're looking for. It's going to be B. So they can ask you to simplify completely. They can ask you to simplify halfway, whatever they want to do. But for number 5, you're really using those 2 formulas that we started with in this lesson. But I want you to see why it's that way. So number 5 is B and E. That's a good question. The maximum volume of a bag that fits in an overhead bin of an airplane is 2772 cubic inches. That is the most it can be. What are the possible dimensions of a bag that has the maximum volume allowed? Well, for this one, we just need to do some multiplying. So on this first one, I'm going to say 8 times 15 times 20 is 2400 cubic inches. Then 9 times 14 times 22 is 2772 cubic inches. 11 times 13 times 21 is 3003 cubic inches. And then 10 times 16 times 18 is 2880 cubic inches. So these two are over the limit. They're too big. This one is under the limit. this one is exactly. So just taking a stab in the dark, I'm going to go with the exact one. That is the closest to the maximum. But the key word here, what are the possible dimensions of a bag that has the maximum volume? So you're looking for one that is the maximum, and that is B. You could use A on the airplane, but this question is asking you for the maximum volume. They're looking for exactly 2772. Number 7, what is the volume of this rectangular prism? And volume is length times width times height. So let's count. We've got the box in front of us. Let's figure it out here. So I'm going to get length first. Let me put my parentheses in there for the setup. Length is this way. So how many boxes this way? There are 5 cubes this way. So length is 5. Width, let me do in a different color. Width is this way. I'm doing it with green. And there are 4 of those. And of course, height is going to be this way. Now I'm going to have a problem when I cross that yellow and blue. It's going to look like another green one, but that's okay. How tall is this block? It is 6 blocks tall. So you can count the blocks and then multiply. Even though I can't see all of them, I can tell you how many are there. There are 120 cubes in this composite figure. I can't see them all, but I know they're there. So number 7 is C. When I taught every day in a classroom, we used to study volume with sugar cubes. We would actually build one of those. And that's a very good way if you have children who are learning this skill. Buy a box of sugar cubes and help them learn how to build different solids using those cubes. It's a very good hands-on way to learn this. Okay, number 8. A box is the shape of a rectangular prism. What is the volume of this box? First thing you want to check is your units. Now, I'm not going to draw a variable box here because I can see it, but I do need to check that all of them are in the same units, and they are. So that's a good thing. All right, length is going to be 8. Width is going to be 3, and height is 4. And the formula says to multiply. 8 times 3 times 4 is 96 cubic feet. So number 8 is A. Number 9. The base of a dog carrier is 12 square feet. Okay, this is important. There's that big B, base. Its height is 3 feet. What is the volume of the dog carrier? So let me draw it for you. I really like to draw this type of problem because of that base thing. That's not always easy to catch. But one clue is that they're talking about square units. So they're wanting us to count, this is the base, right in there. And they're telling me that that is 12 square feet. And then they're counting this as the height, which is 3 feet. So the formula that I want to use is volume equals the big old base times the height. So volume is 12 times 3, and that is 36 cubic feet. So I like B for that one. Sometimes they give you length and width, and sometimes they give you base. But either way, you can do these. Be careful with this one. What is the volume of this solid? So I'm going to take on that top layer, I see 2 of them. And on the bottom layer, count those. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 under there. So when you put all of those together, 12 and 2, you get how many? 14 cubic units. So you could build this one with sugar cubes also. There's 12, 13, 14. Number 11. Randy buys an ottoman, that's a footstool, for his dorm room for extra storage. The inside of the ottoman is 27 inches long, 22 inches wide, and 18 inches high. How much storage space does Randy gain? Well, I'm not going to draw the ottoman, but I am going to draw the variable box because I think that's important. You don't have to, but it will help you not make mistakes. If you have time, sometimes you don't have time to do all this. Okay, so the length is 27 inches. The width is 22 inches. And the height is 18 inches. One thing this does is force you to make sure your units match. And they do, so we're good. 27, 22, and 18. That is length times width times height. And let your calculator do the work. If you have it, make use of it. And that is going to be a lot. 10,692 cubic inches of storage space. So I like B for that one. Okay, number 12. What 2 equations represent the volume of this cube? So I'm going to count the length. It's a cube, so once you get one of them, you know them all. But the length is 3. The width is 3. And the height, if it's a cube, and it is 3. Think of the sugar cubes stacked up there. So height is also 3. So volume would be 3 times 3 times 3. That's length, width, and height, which is ultimately going to be 27 units cubed. But remember, they like to do 3 times 3, that's 9, and then times 3. So let's see if we can get a match here. I see 9 times 3, that's C. And then I see 3 times 3 times 3, that's E. And we just needed 2. I thought we needed 3. So number 12, the two answers are C and E. Let me put this in a box. Okay, number 13. A cereal box is 20 centimeters long, 5 centimeters wide, and 29 centimeters tall. What is the volume of the cereal box? Length, width, height, 20 times 5 times 29 is 2,900 cubic centimeters. So for number 13, I like D. The base of an aquarium is 200 square inches. Its height is 12 inches. What is the volume of the aquarium? So we're looking at this particular formula where the base is 200, the height is 12, so the volume is 2,400 cubic inches. So for number 14, I like C. Number 15. What is the volume of a cube with edges of 5 meters? Now here's the clue. If it's a cube, length, width, and height are all the same. So when I look at length, width, and height, length is 5, width is 5, height is 5. And 5 times 5 times 5 is 125 cubic meters. And finally, Karen loads 5 boxes into the back of her truck. So I'm going to draw a box. And hope they're all the same. Each box is 2 feet long, 2.5 feet wide, and 2 4/10 feet tall or high. What is the total volume of the boxes in Karen's truck? Be careful there. Total volume. 5 boxes, 2 feet long, 2.5 feet wide, 2 4/10 high. So let's get volume. We've got length, width, and height. So length, width, and height. And that all gets multiplied. And that's 12 feet cubed for 1 box. Notice that answer choice is there though. But I have to do that times 5 boxes. So I'm liking 60 feet cubed because it wants the total weight or total volume of the boxes. Okay, we are to the end of this basic volume formula. Practice 42, we will look at some of those weird volume formulas of composed figures. So we will take a look at that one in the next video. But this is practice 41. If you have questions on volume, please do not hesitate to contact your instructor. I hope you have a really good day, and I'll see you soon.